Welcome you all. This is the topic we are talking about strain rosette and strain measurement. Basically, uh, by the end of this topic, we can able to understand or we start to know how to evaluate the strain and what are the methodology to evaluate the analytical steps to measure the strains. Before going to the strain, I just want to talk about little bit on from where this concept has came and why we need to calculate the strain individually, and is it necessary to discuss about the strain. You may recall we have already discussed when the very first class 2 till principal stresses and principal strain, we have discussed individually all the different kind of loading, that means the external loading, the reverse the external loading, as well as the internal loads due to the external loading. In to maintain the equilibrium, the internal load or internal that is called basically what we call it resistive force, or you can say reactive force, it generates within the body and which creates the stress. And stress directly reforms or stress due to the stress some kind of the deformation, or in strain we are calculating, although it comes on the body or the material or the structure or the structural element is under the kind of deformation, and from the deformation we can calculate the strain. Also, or we have already discussed that if the stresses are there, not a single stress will be there in a single, or unidirectional loading will be there, or if that unidirectional load will be there, the deformation may not be unidirectional. All these kind of issues or the stops we have already discussed. Then what is the extra we are going to discuss over here? As the topic says, it's a strain gauge and strain rosette. It's basically terms, or basically intending towards to measurement of the strain by utilizing some of the steps which are known to us earlier during the discussion, or what are the external attachment instrument by which also we can evaluate by what are the knowledges we have, the mathematical concept we have, can we able to utilize that. Although there are some hardwares are there and some of the instruments are there, we can able to find out the strain. Yes, that is there, and how they are working, what is the basic principle behind it, and what are the steps we are going to discuss over, or discuss majority, how we will connect the mathematical expressions corresponding to the hardware we are going to utilize in a practical application or in a real life situation, how to measure the strain. This topic or this class basically talks about that. Now in this context, before going to the directly the stresses or the kind of stresses, the methodology, the mathematical expression, I just want to a little bit focus during the discussion of the stress strain diagram, what we know and what are the stress strain diagram. If we are doing some kind of stress strain diagram, if I'm using some stress strain diagram, or if I'm finding out the some stress strain diagram, then we know we normally utilize an universal testing machine, and there a simple methodology is been utilized. The stress, this kind of machine we have discussed during the discussion of the stress strain diagram. This basically refers to a tensile test machine or universal tensile test machine, and all these kind of machines normally utilizes to find out the stress strain behavior and the corresponding basic properties of any material, corresponding very basic properties. When I am saying we can find out the elasticity, we can find out the strain energy, or we can say the toughness, all ultimate point. All these points we have discussed during the discussion of the stress strain diagram. Now I just little bit extend the same here. I am trying to extend the same little bit before breaking or up to breaking, how it happens, or how the strain is going to be measured. When it start the deformation starts and ends with a breaking at the end of the breaking, how you are calculating all these steps, we know that. And all these conditions, all these experimental condition, we took as a unidirectional loading, and the corresponding, if any structure or structural component is under a unidirectional loading up to failure, how to evaluate the strain, how to the measure the strain. And because strain is the fundamental very fundamental kind of quantity which we can easily see from naked eye. If some deformation occurs, we can see easily, but what is the force or what is the stress, what are the external force is applying, what is the internal resistive force generating, we may not able to see that. But it can be seen easily, although we may not able to measure, but we can able to see there are some deformation is occurring during the or the up to breaking. What is the deformation occurs within the rod or within the gauge length, we can able to measure. So it will give you the basic idea about the, or basic, when I am saying basic idea, I am linking towards what the fundamental output, if I am going, fundamental output will be recorded during the application of the load. It can be easily recorded without any external measurement, or we can see that. We can visually perform the experiment if the experiment is going on. If I am not recording the same, I can visually see the same, or I can visually record the same, and that based on that recording, from the recording frame also I can do the same. So all these kind of possibilities are there. Then how to link what is experimentally happening, how to link with the mathematical expression, what we know. What are the mathematical expression till yet we know? We know about simple stress and strain. We know about simple stress, how to calculate the simple stress if I know the area, if I know the external applied load, and if I know, if I am assuming that the material is in equilibrium, and then I took the resistive force or the reactive force within the body is similar to same equal to same, that means external force equal to the internal forces, then that force, internal force or resistive force for perpendicular area, and based on that we can calculate the normal stresses. Similarly, the shear stress or shear strain we can also calculate, that means the component which is parallel to the body. All these kind of systems or all these kind of mathematical expression are well known to us. During this discussion of the principal stresses also, we have calculated what is the principal stress, and why we should call it a principal stress, what are the component of the principal stresses, that means maximum principal stress, minimum principal stress, and the corresponding or the stress, normal stress existing on inclined plane, shear stress existing on inclined plane. All this kind of stuffs already we have discussed during the discussion of all these different chapters. It's linking to all these chapters till yet what we have discussed regarding the stresses and the strains. Now what extra we are going to do? Now we are trying to investigate, or we just I should say rather, we are trying to establish the relation whatever we know, or the relation whatever the strain stresses we know. Then we are establishing that relation or the mathematical relation with respect to the experimental data what we are going to collect, then how they can be established. Point number 1. 2. What the next we are going to do? Next is if it is the experimental setup, if I am going to record by using some hardware, then on which principle that hardware is going to work. These are the main two principle or two major point we are going to discuss over here in this particular strain measurement class. Now in this respect, just to recall your refresh whatever the known quantity to us, I'll discuss about that. In that respect, you just once again we are recapture whatever the, or recollect whatever the data or the mathematical relations we know. In this respect, we already know what is sigma theta tau theta. That means if it is sigma theta tau theta, again the normal stress, just now I talked about, sigma theta is nothing but the normal stress existing on an inclined plane. If the component, inclined plane means within the inclined, within the a structural, let's say if I'll take a beam or something kind of some kind of elemental stuff if I'll take, and within this beam if I'll take an inclined plane, then if it is under the influence of both biaxial normal and shear stresses, then how to evaluate the principal stresses, or how to evaluate the what are the stresses, not two principals, if I will not say principal stress also, what is the resultant type of forces or stresses are going to be generated within the body. We know this relation, and the corresponding principal stresses also we know. If we know these relations, then what is the use of to know about strain? I'll talk about that. Just hold on a minute. Just we'll complete this one. Like the normal stresses, like the principal stresses, I also discussed during the discussion of the principal stresses and principal strains. I have only talked about the principal strains and their formula, not the other steps, as in the case of principal stresses we have calculated during the analytical method of calculation, both in the Mohr circle as well, because the methodology and steps are as same as the steps we followed in the principal stresses. If somebody knows how to evaluate the principal stresses, just to follow the same technique to convert, after converting, instead of sigma is equal to E into epsilon, as we know sigma is equal to E into epsilon, if I will write all these expressions instead of sigma, if I will write all these expressions in terms of epsilon is equal to sigma by E, then I could able to get whatever the relation I could able to get, or whatever the relation I want to find it out, I can easily find it out from here. Now, as I just now told about, that means the strain is the visually I can able to correct the data, record the data. So the fundamental point I could able to measure or record is the strain. If I once know the strain, that means if it is known to me, and if I know the material, then if I know the material means I know the material properties like elasticity, I can back substitute the value, I can reach the stress, either it is a normal stress, shear stress, any kind of stress, I can able to know if I know the properties. So till yet we know about how to evaluate the properties, or if that means only if the structure or structural component under a tensile loading or a compressive loading, or it is transversely loaded, then how to evaluate these conditions, we know about that. We have not yet touched one other case, like if it is under a twisting moment. We know about bending moment during the discussion of the shear force and bending moment diagram. And we will also know about little bit more if it is under a transverse loading condition during the discussion of bending stress. It will come later on, or it will be a different module we will discuss about that. Now, up to this module, up to this condition, whatever the basic knowledge with us, that means if I apply a normal stress also or normal force also, there is a chance of shear force due to the component on an inclined plane. So how to evaluate, we know that. If I know that, then I could able to find out the strain. How I can able to find out the strain? Now, by utilizing the either by utilizing the analytical technique or by the hardware also. Just now, as I shown the last slide, where I am just I have shown the extensometer, where the extension the amount of extension can be recorded up to breaking. In between, if you know or if you want, then we can record that, and in between also we can up to proportional limit before the plastic deformation, we can also record. Now, nowadays the machines are the machine which are associated with us, they are very much updated machine. Every single point can be calculated or back substituted in that form. Now, corresponding to that, these are the similar kind of, as we know the sigma theta and tau theta. Similarly, we can know about epsilon theta and phi theta, and phi theta here represents the nothing but the like tau theta shear stress, psi theta is, or phi theta is shear strain. the maximum shear strain, or you can say the shear strain on an inclined plane. And the principal strains, here at a time it has been written plus or minus, like here the sigma 1 and sigma 2, and the case of stresses as it has been written, here also the principal strains can be written in this form. Now I know all these points, all of us know about that, we need not to worry about this. That means these are the formulas which are going to be useful. Basically this strain formula or the principal strain formula are going to useful, or we are going to utilize to establish the relation about the experimentally whatever we are calculating, and what analytically and how analytically we will do that. In that context, here also during the discussion of the principal stresses, we have in the last point we have discussed about the same equation. If the x this prime is talking about nothing but the, if I am having a xy plane, and this xy plane at a distance of another, or I am considering another one more plane is x prime and y prime, and we can calculate the strains likewise as just now I have told you. That means the theta angle at a plane up, another plane we can also calculate these terms, and these all are already discussed earlier during the discussion of the principal stresses. The normal strain along the x, the normal strain along the y, and the normal shear strain, all these points has already been discussed. I need not to discuss once again here, because these are known to us, how these normal stresses and normal strains, or so principal stresses and principal strains we express mathematically. These three equations basically utilize, or will help us to find out, or this principal strain what I have shown in the last slide also can be utilized to represent the strain or strain gauge or strain rosette. Then before going to the measurement of strain, and the instrument or the equipment or the small element or hardware we utilize to measure or to record the strain is called a strain gauge. What is strain gauge? We will talk about that little bit. On that, then we will start with the other things. Now, what is strain gauge? Although it is started with the term as a strain gauge and strain rosette, so first I will start with what is strain gauge. Strain gauge is nothing but it's a gauge is a simple device comprising of a thin electric wire attached to an insulating thin backing material such as bakelite foil. Like it is looking like this, the strain gauge is looking like this way, or it is just the outer line is showing it's a filament or bakelite or a plastic. Inside that this circuit is there. You can see these are the resistance measured between these 2 points. If I want to, that means whatever the strain will occur, either there is mechanical strain gauge or electrical strain gauge, and more practically or you can say more precisely, the electrical strain gauge will give you the more precise value. Mechanical extensometer also gives the same, but that can also be done. Or today what else we are using mostly to measure all this direction. If I am applying the load in one direction, then what are the strains occurring in all the direction. To measure that, we utilized basically a electrical strain gauge or a series of strain gauges to make a strain rosette. And what is the strain rosette? I will come to that. Not just you understand. Just I am trying to make you understand. You see all this kind of strain gauges or how it works, or the principle of the working has been shown over here. That means if it is under this strain gauge, if it is along the length of the body, if it is attached to the body along the length, then it will be extended in this direction along its length. It will be extended, so it will be under tension as it has been shown. Or it can be in a gauge intensive lateral forces also. It can be either it will be utilized in a lateral way or along the length. Anyway you will or under compressive loading. Anyway it is going to change the length of this wire or this circuit, or this is creating the the resistance. And if I am increasing, we know there is a relation between a length and the resistance of a wire, and the basic principle of the electrical engineering we know during our basic understanding or basic electrical engineering we have studied. The foil is exposed to a surface of the specimen, that means it will be glued to a surface of the body. Let us say if I am having a rod, or I am having a rectangular rod and it is under the tension and I want to measure the strain, I will just glue the similar kind of one element strain gauge. I will glue at some place near about the, although in the testing what we do 2 gauge point, we put 2 gauge point or 2 points in between the points we say as the gauge length, what we have discussed during the stress strain diagram. Similar thing will occur, and near about the necking point or near about the middle point we place this strain gauge, or we glue this strain gauge about that point, and we try to measure. Either I can put one or more than one based on my requirement or based on my precise I need, accordingly I can put. So, a change in length, when there is a change in length due to the extension or the compression, due to the change in length of the gauge due to the longitudinal strain creates a proportional change or a proportional change in electric resistance will occur. And since a constant current is maintained in the gauge, the proportional change in voltage is V is equal to I into R. The current, voltage and the resistance will be created due to the, or will be maintained based on this equation, the electrical equation what we know. We are going to utilize a mechanical, or we are going to put a mechanical load, but we are going to record by using this V is equal to I into R. This is the basic principle of working of a strain gauge. The voltage can be easily measured by using a voltmeter, and through a calibration transformed into a change in length, and original gauge length can also be calculated from the gauge length also. Now, what is strain rosette? For a general loading on a body, as I just said, just now I talked about that. So, for a general loading on a body, the strains at a point on its free surface are determined using a cluster of 3 electrical resistance. Minimum 3 electrical resistance, or minimum 3 electrical or minimum 3 strain gauges we need to make a strain rosette. This pattern referred to as a strain rosette, that means in which pattern all 3 will be along the length, or all 3 along the width, or all 3 will, how it will be arranged, or where you want to find it out. Based on that, the strain rosettes will be termed as, or they have been classified. Since these strains are measured only in the plane of gauges and body is stress free on its surface, the gauges may be subjected to plane stress but not plane strain condition, because it is going to measure the whatever the strain will occur, it is going to measure the strain part or the deformation part. And once I know the deformation, I know the original length, or I know the instantaneous length also, the corresponding engineering strain or the screw strain, what else I need, I can able to measure it, or I can able to find out those values. Once I know the strain, I know the material, if I know the mild steel or copper or some known material, or if it is unknown material, then we need to go for a tensile test as well to get the Young's modulus. So, Young's modulus, and here from the strain I can find out the stresses. So, corresponding values, all the unknown values can be calculated by utilizing a strain rosette. In a general case, access of 3 gauges, that means access of 3 gauges, when I am saying, just now I said no, if it is a 2D case, or mostly we utilize how to implement, because 2 part in a tensile test, if it is under the tensile testing condition. So, we will have 2 faces, or we will have, if it is a rectangular, since it is rectangular, it is looking like a perpendicular shape you can see. Either I can put a strain gauge here or a strain gauge here. So, what is the third one? It is talking about 3 are minimum required. So, third one I can put at an angle, any angle I need. So, accordingly all this data which will be recorded by individual strain gauges, then I can convert into. So, what is the procedure for that? and that procedure has been explained here mathematically. In a general case, the axes of three gauges are arranged at an angle. That means if it is theta A, if I am considering this is the frame or on which frame I want to find it out, the first one, the angle is theta A, and we know since this strain gauge is going to, or it is already it is on the same axis, so theta A is equal to 0. Let us say it is at 45 degree and the next one is 90 degree. Or it may be possible that I can put it all are into 60 degree each. Like this way also I can put all these three. I can put one here and one here on this side. Likewise I can put according to my interest. I can put either I can change the angle or I can maintain according to the all these three can be arranged. If the readings, once I know the readings of epsilon A, B and C are taken, we can determine the strain component in epsilon x, y, because we know epsilon x, epsilon y or epsilon xx prime and epsilon yy prime, how we have written in terms of theta. If I know the theta, I can put the theta, I can get the sine to theta, I can get the cos to theta, I can able to calculate the values. Like just now I have shown. Here these values are representing these values as I just now said. Let us say theta A, theta B all are known to me, it is given, then I can put all these values, or I can once it is based on the user requirement or user understanding. He can change the angle, he can put the angle to arrange a strain rosette or strain gauge, which one is as per their interest or the person who is observing. It is the based on the observer's interest. So once I know the epsilon x or epsilon A, I know this is the formula by which I can able to get the strain in along A, strain in along B and strain in along C. What is this A, B, C? Already I have said it is theta A, theta B, theta C, or I can put, as I said, I can put directly theta A is equal to 0. I can, it's a generic form has been shown. I can put also on this x-axis itself if I am interested. If I am interested to calculate the strain along the x-axis also. So these three formula majority or these three as a whole, this is a set of formula. One set of formula will be sufficient to give me the strains. Then how to evaluate? Then rectangular based on the placing of the strain, that is the generic form we are talking about. The based on the placing of the strain gauge, the strain rosettes are classified. First one is the rectangular strain rosette. In order to simplify the calculation, the strain gauges are set, defines angles as just now I talked about. There are 0, 45 degree. If the strain gauges are placed at an angle of 0, 45 and 90, then it will be called 0, 45 and 90. Just now I talked about 0, 45 and 90. They will be called as, those are, the arrangement is called rectangular strain rosette or 45 degree strain rosette. And the equation 1 will be converted. Theta 1 is 0, theta 2 is 45 degree, theta 3 is 90 degree. Now putting this equation like 0, 45, that means all are at 45 degree. Each strain gauges are at a distance of 45 degree from the first one. And the first one is at 0, it is along the same length. It is along the same length. I can put a line or a perpendicular line over on this plane, a line perpendicular to this, one in x-axis, one in y-axis and one at 45 degree. Then I just convert what if the epsilon A, epsilon B and epsilon C, theta A, theta B, theta C, I can able to get epsilon x, epsilon y and gamma xy. Then by putting this, all these values, I can also get the responses. The strains I know. If I know the strain, then I'll multiply with the, or I'll multiply if it is mild steel I know, or any high speed steel I know, or any cast iron I know, the values of E, I'll multiply, I can get the stresses. Similarly, equiangular strain rosette. Just now I talked about, also I have talked about 60, 60, 60 likewise. They can be also based on the angles or based on the placing. They have been strain rosettes are classified. One is rectangular, one is equiangular, and equiangular as a distance of 60, 60, 60 or it can be 120. Different arrangement you can see in a different book, different form. Only you have to put the values, and to get the whatever the equation we have talked about, epsilon A, epsilon B and epsilon C, that will help us to find it out. If the strain gauges are fixed at 0, 60, 120, the strain rosette so formed is called equiangular strain rosette or delta strain rosette. And the equiangular strain rosette, the epsilon y, epsilon x and gamma xy can be obtained by substituting the theta 1, theta 2, theta 3 in equation 1, what we have just now we have shown all the discussion. So I can put the epsilon those values, I can able to get the values of epsilon x, epsilon y and gamma xy. Now putting all these values, I can able to measure the strain. Once I measure the strain, I can find out all the unknowns which are required to me, all the unknowns which are that means it gives the connection from input to output. It gives the basic connection between input to output, or it will help us to understand or to quantify if any load will be applied. Basically, strain gauge or strain rosette help us to measure the strains by utilizing a hardware with the help of analytical steps are known to us. This is the all about, and thank you.